Hi and welcome back to another lesson in the physics video series. Today we will be discussing the introduction to the mechanics of motion in the linear kinematics unit. Let's get started. We are going to introduce the first 5 formulas on page 6 of the reference tables, and here they are. Equations 1 and 2 are for average speeds and accelerations, and equations 3, 4, and 5 are for uniformly accelerated motion. We're going to explain each of these, and we're going to show you the graphs that go with them as well. I've broken down the formulas into the 2 groups. In the green group here, we have the average formulas. Average speed is distance divided by time. Average speed is also given as the initial speed plus final speed divided by 2, just like if you take a test average. As you can see, I have a note here. This formula is no longer on the reference table. They expect you to know it. Average acceleration is simply the change of velocity divided by time. In the blue group, we have the equations 3, 4, and 5. They are used for instantaneous motion, or UAM, uniformly accelerated motion. You'll notice that equations 3, 4, and 5 all have acceleration in them, and we are considering instantaneous moments during the trip, whereas the first 3 equations in the green group, they just talk about the overall trip. Let's discuss all of the variables of motion right now. There are 6 kinematic equations. There are 5 variables of motion: VO, VF, A, D, and T. Initial speed, final speed, acceleration rate, distance or displacement, and the time. In each of the equations above, 4 of the variables are given, especially here in the blue group. So if 4 variables are given, obviously 3 pieces of information must be given to you in any problem. That leaves 2 variables left to solve. Usually the first one is part A of a problem and the second one is part B of a problem, leaving one happy physics student. Now let's just explain that there are 2 kinds of information supplied in each problem. Explicit information, that's a number and a unit. You read a question and it says something like 7 meters per second or 3 meters per second squared. Little note in Regents physics problems, all these units, meters per second squared, meters, they're all written out in words. We're going to show you that when we do some problems. Now, there is also implicit information. These are word numbers. These are statements which imply a value and a type of unit. So, for example, if you read words, a car starts from rest. Well, the words starts from rest implies that the initial speed is 0 meters per second. Or it comes to a rest. That means that car, say, is coming to a traffic light and it stops at a red light, so its final speed of that interval equals 0 meters per second. If something falls freely, you read a problem about something dropped off of a high bridge and it falls freely, that means that its initial speed would be 0, gravity would be the acceleration rate of 9.8 meters per second squared. So in every unit of the course, there is explicit information and there is implicit information. Implicit information is tricky because you have to make sure that you recognize the word numbers. Sometimes students read these problems and they say, I don't have enough information, but in reality they may have just simply missed the word numbers, the implicit information. And so to summarize in linear kinematics, so there are 6 equations, 3 in the green group, 3 in the blue group. There are 5 variables of motion, VO, VF, A, D, and T, that appear especially in the blue group. Each equation has 4 variables in it, and when you read a problem, 3 out of the 4 have to be given, with 2 left over, leaving one happy physics student. Thank you for joining us for this lesson. In the next video, we're going to take a look at the relationships of velocity and acceleration. Thank you for watching.